Okay. Today you want to be able to say, I can graph rational functions. And so the idea is, if you have a function that looks like this, f of x is x minus 1 over x minus 2, do you know what that looks like? And after today, you're going to have a really good idea. Remember that, if you want to know what this looks like, the easy way is to just do, like, if you had to draw a picture in 20 seconds or less, and it meant whether or not you're going to win $1 million, what would be the quickest way to try to get a view of that function? What are you going to do? Start with a C. Calculator. Type in your calculator, right? Yep. And that'll generate a view. Well, remember when Isaac Newton, the father of calculus, and other people were going about these problems and trying to figure out what does some of this stuff look like, they had to use other ideas. And so we're going to really use. This isn't the only way to generate these functions. This is just probably, I think, one of the most useful ways to do it. So the first piece is the vertical asymptote. The vertical asymptote is a part of the graph that it approaches, it never touches. And here's how you find it. Where the function is undefined. So, for example, rational functions, if you want to find where it's undefined, what part do you look at, the numerator or the denominator? Denominator, you set it equal to 0. X minus 2 is equal to 0. You solve and you get x is equal to 2. So you have a vertical asymptote at x equals 2. That's a really important part of the graph. So that's one part we're going to look at. Any questions how I got that? Yep. The denominator, if I would plug in 2, I get 2 minus 2 equals 0, and you can never divide by 0. So that's the one spot that we got to be careful of, and so that's why I look at that. For the end behavior asymptote, so we know that we have this vertical piece that kind of changes the shape of the graph, but the question is, what about horizontal behavior? For example, if I was trying to tell somebody a number that's really, really, really far that way, what would you call a number really far in that direction? Infinity. How about a number really far in that direction? Negative infinity. So the idea is end behavior. What does the graph do as it goes really far to the right and really far to the left? Okay. Which number? And here's how we find. Oh, it's the dividend of the rational function. So, if you remember, when we divide functions, we generally get a dividend plus a remainder. We're not concerned about the remainder. The remainder doesn't really give it its shape so much. It's really the dividend, okay? And so we'll do the example right here. We want to take x minus 2 and divide it into x minus 1. So what do you multiply x by to get x? 1. So we put that over our constant. We multiply back through. Subtract. We get 1 as the remainder. So we write that as 1 plus 1 over x minus 2. We don't care about this 1 over x minus 2. All that does for us is tell us that it's still undefined at 2. Okay? What we care about is the dividend. And the dividend is this portion right here. So when the question is what is the end behavior? The end behavior is y equals 1. I'm going to take that vertical asymptote and the end behavior asymptote, and I'm going to draw them on my graph right now down here. So I'm going to go over 1, and I'm going to go up 1, 2. And so my end behavior asymptote, I draw it as a dashed line, And you're going to draw asymptotes for about the next month. We're going to cover some other material that involves asymptotes. In trigonometry especially, they come up quite often. So I have my vertical asymptote and I have my end behavior asymptote. Everybody clear on that? Okay. Let me show you something real quick. Don't pick infinity, but pick a number really far to the right. 200. Okay, we picked 200. Watch what happens when you plug in 200. You get 200 minus 1 over 200 minus 2, or 199 over 198. What number is 199 over 198 really close to? 1. You guys. You see what I did? Come on. X equals 2. I drew X equals 1. Y equals 1. I drew Y equals 2. It's not like I've taught this today already, just 2 times. I did. I'm a genius. Thank you. Oh, there we go. Okay, now the asymptotes are in the right place. All right. So the idea was if you plug in a really, really big number like 200, you get 199 over 198, which is really close to 1. Well, look. Yeah, my horizontal asymptote is about 1. That's what the values are approximately as you go really far out. So that makes sense. That makes sense to us. So we have this kind of shape, okay? Now here's what's going to happen. See how it kind of divides the space up into 4 parts? You're either going to have a graph in the top or the bottom here, or you're going to have a graph in the top or bottom here. And we just have to figure out which one it is. One of the easy ways to do that is to look at X and Y intercepts. Do you know how you tell what a X-intercept is? Do you know how you solve for it? Set Y equal to 0. Do you know how to solve for the Y-intercept? Set X equal to 0. So we're looking for the X-intercept. So I have to take my function, the Y value, and set it equal to 0. 0 equals X minus 1 over X minus 2. How do you solve that? I'm going to write it over 1, and now I can cross multiply. We get X minus 1 is equal to 0. So X is, that's my X-intercept. How do you find the Y-intercept? Plug in 0 for X. X minus 1, I'm sorry, 0 minus 1, negative 1. 0 minus 2, negative 2. Negative 1 over negative 2, Y equals 1/2. So you can see if you plot those points, I'll put those in red. I have X equals 1. I have Y equals 1/2. So we'll see if you connect the dots here. This graph is either going to be in the top part or the bottom part. Do you know which it is now? The bottom part. Why? Because it's going to go through these 2 points and it won't touch the asymptote. So the graph looks like this. It follows very closely to the asymptote. Should be a little bit better curve than that. Let me draw it again. Graph looks approximately like that. It follows the asymptotes. Question? Follows the asymptotes. Can't cross over this, so it's got to head down. You'll see. After you see 3 examples or so, you'll be like, it'll just be second nature. You're like, that's how it looks. Okay. It does go through those points. Well, I think I can actually move it now. Whoop. How's that? Better? All right. Okay. How about here? Do you know top or bottom? We don't. We got to figure it out. We don't have a point, so we're going to make a point. What is an x value you can plug in over on this side? 5. 5 is fine. 5 minus 1? 4. 5 minus 2? 3. 4 over 3. Is that above the line y equals 1, or is it below the line y equals 1? It's above. So therefore, the other graph, other part of the graph, is above that area. Question? Sure. Any number to the right side here would give you an output that would be above that line. Yes. Yes, to some degree. It's yes, it is the image reflected. You could, exactly. You would transpose them over here. However, you may not do this, okay? You see that we're in the bottom and then the top. Sometimes you'll be in the top and then the bottom. Sometimes you'll be in the top and the top. Sometimes you'll be in the bottom and the bottom. So you don't know for sure, is it always going to be bottom and top. It switches back and forth, okay? So that's why we got to be careful with our points and test them. Last thing I'm going to do is this, domain. What is the one number that you can't plug into this function? 2. So x not equal to 2 is the domain. How about the range? What is the one number you can't get out? What's the one number that this graph never crosses? Never crosses, never has an x value of 2, but it never has an output of 1. I don't care what number you plug in, you're never going to get an output of 1. Never. Question? Yes. You could have 2 on the bottom. Yep. Yep. Okay, let's flip over to the back side. We'll do a few more problems together. Yes. Yep. If you wrote x not equal to 2, or you could write negative infinity to 2 and then union with 2 to infinity, either one is fine. Does that answer your question? No, if you want to write x not equal to 2, that's fine. We've already tested on that, so I'm okay with it. Okay. We all know what we're saying at this point. There was a time where I don't know if people understood that those connected. If you don't now, I don't know if it's ever going to make sense. But you know, we've kind of been down that road. So, all right. So let's go to this example, okay? And this one we'll graph afterwards to make sure it looks exactly like we want it to. So let's start with this vertical asymptote. Can anybody look at that and tell me what the vertical asymptote is? 4. The vertical asymptote is for whatever number gives you 0 in the denominator. Okay? That's what we decided on the front side. Whatever number gives you 0 in the denominator. End behavior. How do we determine end behavior? What do? We divide it. So I take x minus 4 and I divide that into 3x plus 3. What do you multiply x by to get 3x? 3. So we get 3x minus 12, subtract 15. So my remainder is 15. So plus 15 over x minus 4. Question, Scott? That same question was asked last hour, and here's my response, okay? As soon as you come up with the constant, you then know what the end behavior looks like. But you could have an end behavior that looks like this. You could have an end behavior that looks like this. You could have an end behavior that looks like this. You could have end behavior that looks like that. You could have end behavior that looks like that. Now my point is this. I'm not going to give you these today, but the point is you have to work it out so you at least get the constant. The remainder after that we don't care about. But we do care about that dividend. So if you want to stop at that point, go ahead. So now that we've done this, what is the end behavior? Y equals 3. So I've got my vertical asymptote, I've got my end behavior. We'll see if you can catch the pattern for what's happening with the x-intercept. The x-intercept, we set the function equal to 0. 0 over 1 equals 3x plus 3 over x minus 4. How do we solve that? Cross multiply. Everybody pause and look at this so you can see what's happening. Does everybody see that when you cross multiply here, what always happens with the denominator? It goes away, and you always just end up with the numerator equal to 0. So from now on, you could just always look at where the numerator is equal to 0, and that will tell you the x-intercept. And in fact, here you get x is equal to 1. I'm sorry, negative 1. How about the y-intercept? How do we find that? Yep, x equals 0. We get 3 over negative 4. Or negative 3/4. Okay. I plug in 0 for x, so 3 times 0 plus 3, and then 0 minus 4. So, I've got some important stuff here. X equals 4, y equals 3, x equals negative 1, y equals negative 3/4. That's the stuff I'm going to put on my graph. Question? Because the rule is to find the x-intercept, you set the y value, or f of x, equal to 0. The rule is to find the y-intercept, you plug in 0 for x. So you can see that one just simply asks me to plug in 0, the other one asks me to cross multiply. See the difference? So when you're plugging in 0 for the y-intercept, just got to, plug it in and see what you get. Plug and chug. Okay. Let's draw the graph. Looks like we've got 4 for vertical asymptote. 1, 2, 3, 4, 5. So it looks like that's my vertical asymptote. My horizontal asymptote was 3. 1, 2, 3. So I've drawn kind of my grid that makes the 4 spots. I've got x is negative 1. So that's, let's see, get that point on here. That's going to be right here. That's x is negative 1. Y is negative 3/4. It's going to be right here. So you tell me for this first part, is the graph going to be in the top or the bottom? Bottom. You see you have 2 points that are below the end behavior. So you're going to put it in the bottom, just like that. How do I determine for the second part if it's in the top or the bottom? What then? Yeah, plug in a number to the right. What's the number to the right? 5. Let's plug in 5. 5 times 3 plus 3. 5 minus 4 is 1. So you get 18. Is 18 going to be above that line or below that line? Above. So therefore, my graph goes above. That's my graph. Question? This part? So when I'm just going to try to generate a point. So like I have 2 points there that give me an indication of where I end up, but I don't know any points over on this side. So basically what I do is I make an XY table. And we just choose a number over on this side. So we choose 5. When we plug in 5, 5 times 3 was 15, plus 3 was 18. 5 minus 4 is 1. 18 divided by 1 was 18. So I have the point 518. Go over 5 and up 18, way up there, you can see that you're going to be above that asymptote. So therefore your graph goes above the asymptote, not below the asymptote. Is that better? If you check my graphing calculator, if I plug this in, and we go parentheses 3x plus 3 divided by parentheses x minus 4, does that look like the graph I have over there? Looks like I'm missing part of it, aren't I? We'll zoom in a standard window, see if we can get a better graph here. Does that look like what I have? Yeah, you can even see that the horizontal asymptote through 3, see the vertical asymptote. Your calculators, your TI-83s, they'll show a vertical asymptote. The TI-84s won't. They don't show the horizontal asymptote. If you want to show that, you actually have to plug it in. So I could put a 3 here and graph it, and now I get it. So, but you can check your answer by graphing it. And again, for people before that graphing calculators, this was a very, very efficient way to graph those. Okay, 2 more. See if our speed has quickened. I'm changing this problem to x minus 2 just over x. Works out a little bit better. Vertical asymptote is where you get 0 in the denominator. Scott says x equals to 0. He is correct. Any questions how we came up with vertical asymptote? End behavior. How do I figure that out? Divide. So we're going to see how many times x goes into x minus 2. What do you multiply x by to get x? 1. Do you want to be done? I mean, everything after that is just a remainder, isn't it? So you could be done at this point. Y equals 1. To figure out the x-intercept, we set y equal to, that's just where the numerator is equal to 0. Where is the numerator equal to 0? To find the y-intercept, what do? Plug in 0 for x. 0 minus 2. Negative 2 divided by 0. Undefined. So therefore, there is none. There is no y-intercept. Because it's a vertical asymptote. So you'll see why you do not have a y-intercept here. As I draw my graph, I've got y equals 1 is my end behavior asymptote. And I've got x equals 0 is my vertical asymptote. Let's pause and look here. My vertical asymptote is right on the y-axis, isn't it? Well, does the graph cross this vertical asymptote? So therefore, is it going to have a y-intercept? No, it's not going to. That's why it worked out the way it did. So these are my asymptotes. Now I mark my x-intercept. My x-intercept is positive 2. So I guess we'll start over on the right-hand side now. The right portion of the graph, is it going to be in the top or the bottom? Now it's going to be in the bottom, because you have a point that is in the bottom. So therefore you get something like that. I would like to know if the graph on the left-hand side is in the top or the bottom. How do I figure that out? I can plug in a number on the left-hand side. -1 is a fine number to choose. -1 minus 2 over -1. What do you get? +3. Is that above or below this line? It's above. So you get -1, +3 is going to be somewhere up there. So basically my graph does something like that. And sure enough, if you were to graph this on your calculator, using your parentheses in the correct places, getting rid of that, you can see that, it's exactly what I have. We did that pretty efficiently. We did that about 3-4 minutes. Okay. So you can see for people back in the day that this was a very effective method to get some quick results. All right, you ready for one more challenging? A little bit tougher? A little bit more exciting? You guys say the others were child's play. It was boring. I know what you're thinking. All right, so let's get started here. What do you notice is different about it? Square and bottom. Vertical asymptote happens when the denominator is equal to 0. How many places is the denominator equal to 0? 2. -1 and +1. Because x squared minus 1 factors to x minus 1 times x plus 1. So therefore you have x equals 1 and x equals -1 as your asymptotes. How do I find the end behavior? You divide. Watch what happens, folks. You're going to take x squared minus 1 and divide it into 0x squared plus 4x plus 0. You have to put the x squared placeholder in there. Yeah, because you don't have an x squared, but yet you do out front. We gotta find out a way to reconcile that. What do you multiply x squared by to get 0x squared? 0. So what is your end behavior? 0. If you carried this out any further, you would just get a remainder. We find that that constant is 0, so that's our end behavior. Let's move to the x-intercept. The x-intercept happens when the top is equal to 0. Where is the top equal to 0? 0. Y-intercept happens when you plug in 0. If you plug in 0 for x, what do you get? 0 over -1 is 0. A lot of zeros here. Let's sort it out. Draw the graph. Then we'll plug in our calculator to check it. We'll pat ourselves on the back for the wonderful job that we did. All right. And, okay. So, there's my vertical asymptote. There's my vertical asymptote. Now here's an important part, you guys. Very important. End behavior. If I'm in the middle of this spot, is this the end part of the graph? No. So you don't have to draw your end behavior in the middle of these two. You can draw it on the outsides. It's completely fine for a graph to, cross over that spot in the middle, just not on the outsides where it's the end of the function. We know about our x-intercept and our y-intercept. Both happen at 0. So I'm going to draw the graph in blue. So we got some interesting stuff going on. We'll see what happens. Let's look at the left-hand side. We don't know if it's in the top or bottom. We have no idea. How can you decide? Plug in -2. Sure, let's plug in -2. What's negative 2 times 4? Negative 8. Negative 2 squared is 4, minus 1 is your answer positive or negative? So is it going to be on the top or the bottom? Bottom. So I draw a graph on the bottom. Let's do the stuff on the right now. What number could you plug in on the right-hand side? 2. And if you plug in 2, you get 4 times 2 is 8, and it will be over 3. Is that going to be on the top or the bottom? Top. Because it's positive, it will be on the top. Now the question is, what happens in the middle? You got all sorts of options. Watch, my finger here. We could start down and come up and finish down. We could start up, touch down and finish up. We could start up and finish down. We could start down and finish up. We just don't know. The only way we figure out what happens in the middle is you try some points. What point could you try between 0 and negative 1? Negative 1/2. Let's try negative 1/2. And we'll get an idea. What's 4 times a negative 1/2? Negative 2. What's negative 1/2 squared? A fourth minus 1. So, negative 2 divided by negative 3/4. Is that a positive result or a negative result? Positive. So you're going to get something up in the top. What's the number between 0 and 1 you could try? 1/2. Let's try that. What's 4 times a half? And 1/2 squared is a fourth, minus 1 is negative 3/4. Is that positive or negative? So you're going to end up with a point somewhere down there. So you can see it starts up along this line. At 0, it crosses over and it finishes down. Now, who's an artist here? All right, so Alexa and Sini, you guys need to rate my graph according to how it's supposed to look, and I want you to rate it on a scale of 1 to 10. Okay? So you got 1 being bad, 10 being good. Okay? Okay, so I plug it in, and now I'm going to, window, we're going to go negative 7, 7, negative 7, 7. Negative infinity? Wow, that's quite a discrepancy. She gave me a 10. All right, well, thank you. I'll take the 10. You can have an A. Alexa, what grade would you like to give me? 9.5, you can have a D. All right. I think that's pretty good, don't you? I mean, come on, compare it to your calculator. Looks pretty nice. Looks pretty nice. Here's your assignments. Do sometime next week. That's not included with the stuff on the board. That stuff's been there for a while. One of those, remember, was before Christmas break.